Good morning, everyone. Welcome to More Muggles, More Macros. If any of you guys were here last year, this was one of our most popular sessions, both online and after the fact and in person. So I'm super excited today to welcome back Josh Horstman and Rich Watson. Let's give them a hand.
Are we on? Yep, we're on. Okay. So I am Professor Watson, and this is Professor Horstman. And we would like to welcome you back to the second year of SAS Innovates School of Witchcraft and Wizardry. It's great to see all of your smiling faces, and we are going to hopefully teach you new ways to use a macro or magic that we taught you last year. So last year, we taught you macrotize mycodia, and so we hope that you've been practicing that this summer. So we're going to show you some enhanced techniques for this particular macro magic.
All right, so I've looked at a lot of SAS code since last year, and I hate to tell you guys, but the dark forces of hard coding are still active in the world. So we're going to have to use our macrotize mycodia spell that we learned last year with some new advanced techniques that we're going to teach you this year to try to keep those dark forces at bay and rid all of our code of those pesky muggles.
Now, Professor Horstman, we may have some new students this year or maybe some transfer students, and so we have to explain to them what you mean by muggles.
All right, so muggles refer to those static little bits of hard coding that are in your code. So any kind of hard-coded logic that is inflexible, doesn't adapt to your data, doesn't adapt to your computing environment, they make your programs rigid and more difficult to reuse, more work to maintain, and so you're constantly having to change your code because your data changed, some other input changed, you're running in a different environment, you got to change your code. We're trying to eliminate that, and we're trying to use macrotize mycodia to create beautiful, data-driven dynamic code using macro tools to generate our SAS code for us.
So like every good witch and wizard, we must practice to hone our skills. And so we do hope that you've been practicing macrotize mycodia over the last year. So that was last year's class was teaching you and preparing you to pass your OWLs, your ordinary wizarding level exams. Now we're going to start preparing you for your newts, those nastily exhausting wizarding tests. And in order to do that, we're going to do a real quick recap of the OWL lessons that you were taught last year, and then we're going to enhance our skills by using control tables, and then we're going to execute a neat little macro trick with call execute, and then lastly, we are going to resolve to pass our newts using a resolve function. So last year at the School of Witchcraft and Wizardry, we gave a class on from Muggles to macros. This is available online in the Ask the Expert webinar series, and so you can go online to get that information. In that particular class, we taught you more about the macro language facility, as well as gave 7 examples of data-driven techniques to help take the Muggles out of your code.
Now, unfortunately, we don't have time to go through everything we covered last year again this year, so if some of these concepts are new to you, then please go review last year's recording, and that'll catch you up. But I am going to provide just a brief recap on some macro language basics to make sure everyone's on the same page of the spell book. The main thing to take away from last year was the idea that the macro language is a separate language from the SAS language, and it writes SAS code for us. It's a powerful tool. And so when you submit SAS code, there's a lot going on in the background. So ordinarily, you have something called the word scanner that parses your SAS statements into tokens, which are the individual bits of syntax, like operators and keywords, things like that. And those are sent to the compiler for syntax checking to make sure we don't have any dark forces at work in our code. And then, once the compiler is done, the step is executed when the step boundary is reached. In other words, when you get to the end of a data step or a proc step, execution occurs. However, while that's going on, the macro processor is lurking in the background looking for macro language elements, which are indicated by a % or an ampersand. And if it finds some macro language code, then it routes that to a separate process where macro variable references are resolved, macro statements are executed, and any other macro logic is processed. That process can produce some output, which has to be rescanned to check for additional macro language elements. So it's an iterative process, and once the macro processor determines that the code no longer contains any macro language, it's all just text as far as the macro processor is concerned, then it's sent to the SAS compiler like ordinary code to be compiled and executed. So it's important to understand the timing of these things because macro variables are resolved during macro processing, which occurs before your SAS code is compiled and executed. And so, as we saw last year, that timing becomes a key thing to understand as we look at some of these tools, which we will get to in a moment.
And you want to review the webinar that's recorded on the Ask the Expert. It goes into a lot more detail about the processing of macros, and so we encourage you to go and look at that recording from last year.
All right, now one tool we introduced last year is called the macro variable list, which is just a structured way of using a sequence of macro variables to store a sequence of values. And the idea is that you have a bunch of values, you put them into a series of macro variables that have the same name except for a numerical suffix, which is sequential. So for example, we did an example last year where we needed to do some processing on the sashelp.cars dataset, which is one of the sample datasets that ships with SAS. And we needed to do something for each unique value of the variable called origin, of which there are 3. If you've looked at that data set, you probably know that. Asia, Europe, and USA are the 3 unique values. But we didn't want to hard code those in there. We wanted to write code that was data-driven. And so we created a macro variable list, and the list had 3 variables, origin 1, origin 2, origin 3, which contained those 3 values. Now, you see here on the screen some %let statements. That's not what we want to do. That's Muggle code, right? We're hard coding based on those data values. But what if our data changes later? What if we get a 4th value later? I want to write code that is not dependent on the specific values in my data so that when they change, I just hit run and my code adapts. So in order to do that, we have to be able to get data values into our macro variables. We don't have the data values until we get to execution time, but macro variable, like the %let statement, that executes during macro processing. So that's where that timing issue comes in. And last year we introduced some techniques which we'll recap when we get into one of these examples. Using proc-SQL or using a data step, they both have ways that allow us to put values into macro variables at execution time so that we can use the macro language to build data-driven code. And again, recapping from last year, once we had those values into a macro variable list, we wanted to access them. Now, normally you use an ampersand to refer to a macro variable. So ampersand origin 1, when the macro processor sees that, it tries to resolve that macro variable reference, and we had stored the value of Asia in there, so it would simply replace amper origin 1 with Asia, and then execute the code. Likewise with amper origin 2 and amper origin 3, but we wanted to be able to do this dynamically in a loop where we don't know in advance how many elements are in the list. So you see here at the bottom, I have a macro %do loop that's going to execute iteratively. And I've got another macro variable called num_origins, and we'll show you in a minute how we created that, that contains the number of unique values of origin, because again, I don't want to even hard code that number in there. And this is just a simple loop that just does a %put, but the key here is, in order to look up the ith element from my macro variable list, I need to do some special syntax. I can't just say ampersand origin ampersand I, because the macro processor will interpret that as 2 separate macro variable references, and that's not what we want. We use this double ampersand notation, and so when we put ampersand ampersand origin ampersand I, the double ampersand resolves to a single ampersand. You just have to remember that. That's how it works. Origin is the next token. That's treated by the macro processor as text because it's not a macro language element. And then ampersand I, that's our loop counter. So the first time through this do loop, that resolves to 1. So you have ampersand origin 1. But remember earlier, I mentioned that macro processing is iterative. So when this comes out of the macro processor, amper origin 1, hey, that's another macro variable reference. So it makes a second pass, and now it goes and resolves that to Asia. So the first time through the do loop, when I is 1, amper origin amper I resolves to Asia. But the second time through, it will resolve to Europe. The third time through, it will resolve to USA. And in this manner, I can process the elements from my list without ever hard coding the values or the number of values, so that when my data changes, I don't have to change my code. So I wanted to recap that tool because it's going to come into play in the examples that we're going to present.
Right. So Last year you were given a spell book, your monster book of spells, and so we're going to take that book out and we're going to add new techniques to this book so that we can show you how to use more advanced techniques with the macro language. And so we're going to practice macrotize Mycodia, we're going to add new techniques, and one of those techniques is using control tables. So in this example, we're going to show you how to use a control table with your programming logic to make it more dynamic. Control tables typically are something like an Excel file or a text file or some kind of database that lives outside of the program. So before we can cast that spell, we have to give you some background on how to use some of these techniques, and one of them is the live name. We're going to use the live name to read in a control file that lives outside of our data. So this file is going to live somewhere else, not in the program. And so we're going to use the live name to point to a particular reference. And so we have our live reference, which is our shortcut, our nickname for where our library is, which is our full path of where we're pointing to a particular file or a particular location. And then we have our engine. And so in our example, we're using XLX, the Excel engine. And so that is our engine. And we're going to use that to read in our control table, which is a spreadsheet, to control how we're going to start using or writing macro calls.
Okay, so for our first example, the goal is going to be to create a series of summary tables, and they have the same structure. It's essentially the same table shell, but they have different titles and footnotes because they're based on different subsets of our data, so different subsetting criteria. Now, the Muggle approach would be first write your SAS code for one summary table, and then copy it, paste it down below, change the title, change the footnote, change the subsetting criteria, change anything else you need to change, and keep doing that for as many tables as you have. Now that, of course, can get pretty cumbersome, as we will see in a minute, especially if you have a lot of tables to do. But then we're going to show you the macro wizard approach, in which we create a SAS macro that generates the summary table and accepts some parameters, such as titles, footnotes, and subsetting criteria that control the various aspects of that table, and then we will manually call that macro with different parameter values for each table. However, this still has a degree of hard coding because of all the values they're essentially hard coded into the parameters. So we're going to go a step further to our advanced macro wizard approach, and we're going to place those parameter values into a control file to get them out of our code entirely. And that's where we're going to use the live name statement that Professor Watson just described so that we can create code that doesn't have to be changed. The only thing we change is our control file, and we just run our code again.
So here are our reports that we're trying to produce. And for this particular one, it's an adverse event table. It's using all of the adverse events within the database. And so you'll see that we have our structure, we have our column headers, we have a title, we have our row labels as well, and we have footnotes. Now, we want to replicate this particular output, but we want to do it for serious adverse events. And so you'll notice that the structure is exactly the same. The only thing is different is the titles, the footnotes, and the subsetting criteria. Want to replicate it again for our adverse events that are related to study drug. And so you'll notice that the structure is exactly the same. The only thing changing is the titles, footnotes, and the subsetting criteria. And so, as we've mentioned, we can do this the Muggle way. The Muggle approach would be to manually code this for every single output. And so we would copy this code. We have our nice little lovely code for all of our adverse events. And we're going to copy that code for every summary table we want. Now remember, we're doing this the Muggle way, which is no macros at all. So we're going to show you how to start using the macrotize Mycodia, but we've got to show you the Muggle approach first. So we're going to do this for every single output. And you'll notice that we now have adverse events for serious adverse events. And so now we have a where clause on our in our proc SQL to subset the data. Our titles are changing, our footnotes are changing, and then we're going to do this again for the adverse events that are related to study drugs. So we have to repeat this over and over. This is just for 3 outputs. I actually had to produce a report with 500 adverse event tables. I did not want to do it that way, so this is where macrotize Mycodia comes into play.
Absolutely. So that approach can become very cumbersome and error-prone if you have to do a lot of tables. So there's going to be a better way using the macro language. So the first step is we're going to make a macro, we're going to macrotize our code by putting all the logic necessary to create one table inside of this macro. And here's the definition. You can see we go from %macro down to %min at the end. So this is a macro definition, and it accepts a number of parameters at the top. And these are the things that are going to change from table to table, right? So the titles, footnotes, subsets, table number, whatever might change with each iteration. We've suppressed a little bit of code in here just for space, and I've also introduced a sub macro, a nested macro here to create the select statements in my proc-SQL to make it a little less cumbersome. So we can use the macro language to generate those elements individually, and then those go into our bigger macro. And then down here at the bottom, we still have our titles and footnote statements, which are simply using those parameter values that we passed in, and then we call proc report, and we get our output. Now, this is just a macro definition. We have to call the macro to actually create a table. So after the definition, then we have calls to the macro. So as you can see, here's for 3 tables. I have to make 3 calls, and in each one I pass in those values that pertain to that table, the table name, table number, titles, etc. So this is better than what we had before because I'm only writing all that code once, but in a sense, I've simply moved all of my hard-coded values into one place in the code, here where I have my macro calls, which it's an improvement for sure, but we can do even better than this. Because still, if I had 100 tables or 500 tables, this in itself would become quite cumbersome, and there's still a lot of copy, pasting, changing, making mistakes, things like that. So we are going to go and look at how we can use a control table to make this approach more dynamic.
Yeah, so we want to prepare ourselves and fortify our defenses against the dark arts. And so what we're going to do is, like, you're probably wondering, why am I introducing a spreadsheet? Isn't this a macro class? Well, the spreadsheet is where we have our control file. This is where we're going to save all of our stuff. In the industry that Professor Horstman and I work in, that we have sub-careers as well, in the life sciences, we typically have some kind of file that controls all of our titles and footnotes. So we add an additional point in here where we have a subsetting criteria as well. And so you'll see that there is 1 row per macro call, and then we're going to have all of our parameters, our macro parameters, is going to be 1 column. And so this is going to be our control file. And the key is that this lives outside of the program. The program is never going to be retouched. Ideally, it should not be retouched. We're just going to update everything in this control file, so that way we're not having to revalidate. So in the life sciences, there's always 2 programmers, and everything always has to be revalidated if you touch a program. And so we're trying to get away from that. And so we're going to use this to create our actual macro variable lists. And so as Professor Horstman introduced during our recap, macro variable lists, there's different ways to create one, and here is one of them. And so we're using that live name with the XLSX engine to read in a spreadsheet. And you'll notice that it does have the full name, including the extension of the file. It's pointing to a specific file, and then it's going to point to a specific worksheet. So you'll see that I have control.tables. There is a tables sheet in our workbook, and it's going to point to that specific worksheet in our workbook. We're going to then use a little different type of magic. I like to call it the SAS language magic. It's not macro magic, but it's still a little bit of magic. So we're going to have this underscore variable sitting in the background that's going to count the number of records that are being read in. We're going to use that to build our macro variable list, and so it's going to be sequential. And so we're now creating, 7, 8 new macro variable lists based off our control table, and we're going to use that to build, output name 1, output name 2, etc. And then you'll see the EOF. We have the end equal EOF. If it's the end of the file, we're going to now output another macro variable that tells us how many rows we read in, so that we know how many times to loop through in our macro processing.
So when we're done with this process, what we have is a whole bunch of macro variables containing everything that was in that Excel spreadsheet. Right? All of the subsetting criteria are in macro variables, subset 1, subset 2, through subset 500, if that's how many rows we had in our spreadsheet. Right? The output names are in output name 1, output name 2, all in macro variables. And this call symputx is a data step tool that lets us create macro variables during data step execution. That's what makes this work, because we have to wait till execution time before we actually have access to our data values, and now we stuff them all into macro variables. So we have all those macro variable lists, plus the one additional one that Professor Watson mentioned, the num outputs, which tells us basically that's going to control our loop. How many outputs are we creating? So now, once we've created all those macro variables, we need to do something with them. So what we're going to do is call that table macro that we showed a few slides ago, T_AE. That's the macro that creates one table and takes a bunch of parameters. But instead of passing in hard-coded values, we're going to pass in the elements from our macro variable lists. And here's where that double ampersand notation comes in that we spoke about earlier. So for example, the parameter output name is amper output name amper I. So when I is 1 the first time through this do loop, then the macro call is going to have whatever is in the macro variable called output name 1, which came from the first row of the Excel spreadsheet, whatever that output name was. That's what gets passed in as a parameter value, and so on for the rest of the parameters. So this do loop runs the number of times equal to the number of outputs that we're creating, and each time it passes in all the parameters that it read in from the Excel spreadsheet into the macro variables for that output. And when we're done, we will have a set of table outputs that look just like what we had before. So the same outputs that were created, but everything that controlled all of the attributes of these tables was in our control file, not in our code. And why is that so wonderful, Richie-Ann?
Okay, so the reason this is having everything outside of the program is because if you go here, you'll notice here in our updated spreadsheet, we realize we're re-reviewing our outputs and we're saying, oh, one of our outputs did not have the right counts. They didn't have the counts that we were expecting, and it's maybe because we didn't use the correct variable when we were subsetting. We can easily update our control file, and we don't have to touch the program. We just update the control file and rerun it, and it will now use the correct selection criteria. But the other thing is what if it's a Friday night, you're getting ready to go to Hogsmeade, you're getting ready to get some butterbeer, and you're super excited because it's the weekend and you're ready to go, and your boss walks in and says, oh, I need this extra table. The Muggle approach would be met with groans because not only do you have one programmer that has to now produce the table, you now have another programmer that has to actually check the table to make sure it's correct. So now not only did you interrupt my day or my evening at Hogsmeade, you're probably interrupted Professor Horstman's evening at Hogsmeade as well. And so with the control table, we just enter the information in the spreadsheet, we run the program again, and it's going to now give us the correct table that they just requested on 5 o'clock on a Friday night with the correct titles and footnotes. And that was quick and easy. We didn't have to sit there and disrupt our evening of fun.
All right, so there we have the output. It's, we now have 4 tables instead of 3, and we could easily extend this to any number of tables. We just add additional rows to our spreadsheet as Professor Watson described. Yes, and so that helped with that 500 outputs that I had to produce. I did not have to sit there and manually type all that stuff. All right, so macrotizing our code has created code that is dynamic and it's data-driven. It's basically driven based on what we put in that Excel spreadsheet, and the macro language allows us to generate that SAS code dynamically. We're going to turn to another example, and this time we're going to use a new incantation called call execute. Now, call execute is a data step subroutine. Subroutines are kind of like functions. They accept arguments, but they don't return a value. But call execute's a pretty unique subroutine, not like really anything else in the SAS language. The argument we pass in to call execute is actually code that will get executed, but it doesn't get executed until the current data step is done. It just gets added to the input buffer, and then when this data step is done running, that's the next thing to run before whatever else is further down in your code. And we can call it multiple times within a data step and keep adding stuff into the input buffer at the end of the current data step before the rest of the program. So we're going to use this along with the macro language to do some dynamic programming. So before we can actually show you the code, we have to set the background and understand what we're trying to produce. And so in this particular example, we're trying to produce a series of figures. So there's a number of laboratory tests that are being done, but we only want to produce a figure if there's at least 20 subjects with a post-baseline assessment. In addition, we want each figure to have, each laboratory test to be its own output, and we want the y-axis to be controlled based off the information in the data. The Muggle approach would be,
review your data, look at this and look at all your data, do some proc frequencies of the data to see how many, tests had 20 subjects in there. Then after I do that, figured out which test I need to review or create a report for. I'd still have to go back and review that to get all of the y-axes, the min and max. And that's just preparing. I haven't even started programming my SG-plot. I'm already tired just by doing all this review because I would have to repeat this exercise over and over every time we got new data cut. So the macrotize mycodia approach would be, we're going to do this by putting that SG-plot into a macro, and then we're going to use call execute to determine when we're going to run a particular lab test. It's going to use we're going to do some processing to say, okay, we have 20 subjects, now we can create a macro call, and then we're going to run that macro. So that's where call execute. It's very powerful. It can be hard to use and be tricky, so this is why it's called NEWTs, the Nationally Exhausting Wizarding Test portion of our class, and so it can be a bit tricky. So we're going to have these desired outputs, and you'll notice here, it's kind of hard to see, but you'll see that the y-axes are different for each of these figures, and that's one of the things that we have to control for. Again, the Muggle approach would be to examine the data and manually code that information, and we want to take that hard coding out, those Muggles out, so that we can now have it data-driven.
All right, so let's look at the Muggle code here. So the Muggle approach is first we start with the first lab test that happened to have 20 subjects worth of data in it, and it was this albumin. And so we've got our ODS RTF statements at the top and the bottom to create our output file, and we've got a proc SG plot in between, and you'll notice the proc SG plot has a where statement to subset the data. There's a title statement to put the right title. Down here on the y-axis statement, I've hard-coded in my minimums and maximums. So that just creates one lab figure, and then I have to do this for every additional lab figure that I want to create, and I've got to manually check, as Professor Watson indicated, which ones had the 20 subjects. Right, and so a big problem with this approach is, at least in our work, we get iterative cuts of data. If you're working on a clinical trial over the course of years, every month or two or whenever you get a new cut of data, now I got to go through and check again, well, which ones have 20 subjects worth of data, and what are the new minimums and maximums. It's a lot of extra work that I don't want to deal with. So that's the Muggle approach. Professor Watson, this is insane. There's got to be a better way.
Yes, and I see that the dark forces are trying to creep back in. We don't want those dark forces creeping into our code. And so we're going to now introduce the use of call execute here, but we're first going to create our macro definition. And so we're going to just take one of the pieces of code that we used on our SG plot, and we're going to take that and we're going to now parameterize a lot of this input. So you'll see that the code looks exactly the same. The only difference is now instead of hard coding the parameter or the title or the min and max, those are now going to be macro parameters. And so after we've created our definition, we still now have to do our macro calls. And so you'll see here, manually type this. So this is still, macrotize mycodia. This is more what, AL level. So, last year, we passed our ALs. So this is how we're going to do it. And that's great. That's perfect. The only difference is now you'll see that I had to do a little bit of ellipses because there was a lot of tests. I still have to go in and examine what the min and max is. I still have to now say, okay, these were the tests, last month, but are these the same test this month? Do I have to have more macro calls to produce a different output? And so we're now going to do the advanced wizarding approach, which is what we're using called execute. And Professor Horstman, can you elaborate on how to use that?
Absolutely. So remember what this looks like here, because what we're going to do is generate these macro calls, but we're going to do it dynamically based on the data without having to type all this stuff in. So here's a data step. It's a data null, so it doesn't produce an output data set, and it reads in our original lab data. So we haven't done any processing on it yet. Now there's a comment there. I've suppressed some of the code because there's a little bit too much code to fit on one slide. So there's some bookkeeping code I'm not showing you. But what this is doing is going through every record in the lab data set. We're accumulating a minimum and maximum value to use for our y-axis range. And then when we get to the last record for a given lab test, that's param code. You see if last.param code right in the middle there. Then if we're at the last record, we continue processing and we build this macro call. So that's what this mac call equals assignment statement's doing. Right above it, you'll see if num suj greater than 20. That's a subsetting if. If we don't have 20 subjects, we quit executing that iteration of the data step and go back to the top, so we won't create the output if we don't have 20 subjects. That's all done for us dynamically, so we don't have to do that manually. We build the code here, and you can see we're building with a cats function, we're concatenating together the pieces that we need to build those macro calls that we showed in the previous slide. And then we're passing that in to call execute. And that's what's actually going to place that macro call onto the input buffer. You'll notice the %nr_str around it, that's just a quoting function because we don't want the macro language processor to go ahead and try to resolve macro references now. We don't want it to do that until we're ready to execute that macro, so it's masked for now. And then once it gets on the input buffer, then it will be submitted. The macro processor will do what it normally does.
And you also have to mask it on the cats function, which is why there's single quotes versus double quotes. You want to mask all of the macro language triggers when you're building that kind of information. Otherwise, it's going to go and try to execute or go and try to resolve that macro language.
Exactly, because when we submit this data step, the macro processor looks at it first, tries to see if there's any macro language elements in it. And this is, none of this is actually macro language code. This is all just plain old SAS code, so we don't want the macro processor doing anything with it. Once we make that macro call submission, then the macro processor will replace those calls with the code that's generated by that macro. And you can see in our log, it shows you what code was generated by call execute. So for example, for our first lab test, albumin, you can see it generated the ODS RTF and the title statement and the proc SGplot. All that code was generated and then executed when that macro was called. So all we did was submit one data step that had the call execute, and of course we also had submitted our macro definition before that, and now it goes and calls the macro. So that slide I showed you a minute ago that had all the macro calls with all those values hard-coded in, now that's all automatic.
And you don't have to sit there and examine your data. So that's why we did it in a data step. So within a data step, we're doing a bunch of retains, doing a bunch of counting of results, doing those different types of min and max functions to start gathering the various pieces of information that we're going to build our macro call. And with the use of call execute, it built the macro call, and then once we hit that step boundary, that run, it ran all of those macro calls for us, wrote the exact code that it was producing to the log. And so you can always go and look at that log to see what it is producing, what it's writing.
And what we get is the same figures that we had when we did the manual approach, but it was all data-driven. So that's call execute. Now we're going to talk a little bit about another tool that you can put in your spell book, which is the resolve function.
Okay, so this is going to be our last incantation for our newts class. And with the resolve function, typically when I mention the resolve function, I get a bunch of strange looks because people are like, I didn't even know SAS had a resolve function. What does the resolve function do? So there are several functions that are part of the data step that work with macros. We're only going to be talking about the resolve function right now. And what it does is that it's going to take an argument, one argument, and it's going to now, whatever that argument is, it's going to resolve it. It's typically going to be a macro expression or something that resolves to a macro expression. And once you get your macro expression, that is going to resolve it and go to the macro language facility to resolve that particular expression. Whether it's a macro call or a macro variable, it's going to resolve it at execution time, and it's not going to go out beforehand, because if you go back and look at the Ask the Experts webinar, we talk about that where in the process is the macro stuff being resolved. It's done prior to ever executing the data step. But in this case, we want it to resolve during the data step, not prior to the data step.
Exactly. So for the example to show off the resolve function, we are going to create some reports. These reports are just frequency counts. And each cell of the report, I'm going to show you the report on the next slide. It's got a count, it's got a percentage. The percentages are based on population totals, and the population totals, the big N values, are going to be shown in the column headers. So the Muggle approach for this is that we're going to have one proc freak to determine our subject counts that go in our headers, and those become our denominators for computing these percentages, and then we're going to have to manually code those numbers into the column headers, as well as merge them into our data so we can derive our percentages and put those in a proc report to create our table. The macro wizard approach is going to involve macro variables to store those header counts, and the resolve function to resolve them at data step execution time so that we can compute the percentages. So here is the desired output that we would like to create. Notice the big N values in the headers of each column. So each treatment group has an N, and that is also the denominator that's used to compute these percentages in each of the cells within this table. So here's our Muggle code. First, we've got at the top a little proc freak that's just to determine the subject count for each treatment group. And you can see the right-hand side of the screen there. It just creates this little tiny output data set that has 1 row per treatment group and tells us how many subjects are in that group. And then we have another proc freak. This is to do the actual frequency counts that are in the body of the table, and we're using the ODS output to get the cross-tab freaks output data set. There's some additional code that I'm not going to go through for sake of time to merge those two data sets together to create a data set that we're ready to feed to proc report. But here's the proc report, and the important thing to notice here is we've hard-coded in those N values. Right? This is the Muggle approach. We had to compute them, and then we had to hard-code them into the headers, the titles for those columns. And that's what we want to get away from, because this means every time I get a new data cut, I got to go figure out again what those N values are and then update my proc report code so that they will be correct. And then in addition to that, what if I have more treatment groups? Right? There can be situations where additional treatment groups are added over time to the data. I would have to go add new defined statements, modify the column statement to include those in my report. So it's a very manual process anytime I have to update this. So Professor Watson is going to show us a better approach using some macro magic.
So we're going to resolve to get the dark forces out of our code, right? So we're going to use the resolve function to do this. But before we can do that, we have to create a macro variable list. So earlier we showed you how to create macro variable lists using a data step. Here's another technique for creating macro variable list, and this is using proc SQL. So we're going to now create a series of macro variables list, one that has the treatment number, then the N, the number, the overall counts, and then the label. So we have the, thank you, Professor Horstman. So these are the macro variables that we are creating with proc SQL. And so we're creating this information, and we're going to use it later on to build our report. So rather than doing a proc frequency and then merging that proc frequency in with our cross tabulations, we're just going to do a cross tabulation, and we're now going to use the macro variables from the macro variable list to start creating all of our other information needed for our report.
Yep, one thing to point out here is on the N2 clause on our select, you'll notice we have T1 dash, N1 dash. So each of those is creating a list, a sequence of macro variables, and we don't have to specify an upper bound. Proc SQL will automatically create the correct number of macro variables to hold the number of values that were returned by the query, which is great because we don't want to hard code that number in there.
Yeah, thank you, Professor Horstman, because if we do get another treatment, it'll automatically update and create the next level, the T4, N4, and L4. So with the resolve function, so we went straight from our cross-tabulation data set into creating and prepping our data set. We didn't have to do any sorting or merging. We're just going to use the data, the cross-tabulation frequency data as is. We're going to create a denominator. And here you're going to see that we are going to build a macro variable that can be referenced from the global symbol table. So I'm using the ampersand, and you'll notice that it is in single quotes. And the reason it's in single quotes is because we have to mask it. If we don't mask it, it's automatically going to go, again, where you are in the process. If it sees the macro language trigger, it's going to try to execute that first and resolve all that first before we ever get into the data step. There is no ampersand in our global symbol table. So we are going to build our macro variable within the data step based upon the information in the data. And once we get that information, we are then going to resolve it. We're going to say, okay, now I've built my macro variable. I'm now going to go to my symbol table and resolve this information. So I'm going to use the cats function with the ampersand, and then I'm going to use this variable trt01pn, which is going to contain a number 1, 2, 3 to indicate what treatment we're on. And so it's going to use that, and it's going to build an ampersand1, an ampersand2, or an ampersand3. Once it's built that macro variable, it is now going to resolve it immediately right there in that data step. And we're going to now use that information to create our frequency, our percentages, and then create the result that is going to be produced on our report. And so you'll see here we have our denominator variable, and you'll notice that it does correspond to what is in our global symbol table. And it's being based off of that TRT01PN variable. So you'll see 1, 2, 3, 1, 2, 3, and it does correspond to what is in that global symbol table. And so we were able to do that on the fly. So as more treatments are being added, we now have that information in there. As the counts are changing, we're not having to do a lot of hard coding. And so when we create our report's going to be done in a macro definition, and what we're going to do is we're going to, on our column statement, we're going to use the percent do to now build our list of variables that are going to be in our report. And so we see here, we're using that amper_num treat, which came from our proc SQL, and then now we're going to do TRT amper I, and so it's going to now build our list of variables that are going to be in our report. So TRT1, TRT2, and TRT3. So it's building that, and then now we're going to use the same technique for our define statement. So remember the define statement had the label, the drug that we were using, along with the counts. We're using that information from our macro variable list that we created to now produce our labels for our headers.
Great, so we've built the column statement and the define statement dynamically using the macro language.
Yes.
All right, so what do we get, Rajan?
So we get the exact same report that we had previously, but the beauty of this is now as the data is changing, as we are getting more data cuts, the counts are going to change. If we get a new dosing level, it'll automatically be put onto the report without us having to change the report.
Wonderful. All right, so just to wrap things up here, the macro language is a powerful tool for us to create data-driven programs. We can use it to write SAS code, and we can allow our data to drive the programming logic so that we don't have a bunch of muggles, a bunch of hard coding that are going to create problems for us later. We can build beautiful dynamic code that is easy to maintain, easy to reuse for another project, or reuse across different iterations of your data without having to require extensive changes and rework, which we like to avoid. So then later, we can be enjoying a nice, cool butterbeer instead of modifying our code. All right, I think we've got just a few minutes here for questions, if we have any.
And if you do have a question, we have, we stopped at Honeydukes on the way in, and so we got you some nice little treats for those of you that would like to ask a question. Now, if you're asking virtually, sorry, we can't ask.
We can send it by owl.
I do have a virtual question.
Okay.
This was when you guys were looking at example number 3. Does using macros this way add substantial processing time?
Good question about processing time. Richanne, any thoughts on that?
I personally have not seen it, but I also don't work with like a lot of data sets. If I have huge data sets, I typically will convert to using a hash table or something, but then there's other techniques. But with the data that we use, we've never seen an issue with that.
Yeah, I mean, there's two different resource issues here. There's compute time, but there's programmer time. So in our situation, programmer time is a lot more valuable, so we're trying to optimize for that. I still think that the macro facility is pretty efficient, but I will have to admit I have not tried this with billions of records because we just don't deal with that level of data. Anyone in the room have some experience that would shed light on that?
Got one back here.
So I'll admit I haven't implemented some of these functions, but I do deal with large Medicaid data sets with billions of observations. The only thing that I've run into is sometimes when you're going through that many observations, you can run into memory issues.
Yeah,
if you're doing a lot of steps within a macro, we can run into memory issues with the working library and some disk space. So as long as you have the space, I don't think that it adds any like real processing time.
Yeah, that's a good point because you are creating a lot of macro variables, and so at some point you would start to run into memory limitations. Any other questions?
I believe.
Hello there. I know we have a simget function that does the same thing as resolve, so I want to understand what is the context.
I'm glad somebody asked. Thank you.
Okay, the question was about the simget function.
Yes.
Yes.
So simget is very similar to the resolve, and that's what most people are used to seeing is the simget function. Simget, the difference between simget and resolve is that resolve is a souped up version, and so this is newts, and so we want to show you the most powerful function that you can use. Simget only resolves a macro variable, whereas a resolve will use a macro expression, so it could be a macro call. So that's the difference.
Yeah, good question.
One more?
Yeah, in your examples, I saw call input X, and now in my experience, it's less efficient to do that than to do proc SQL with multiple into statements. Have you seen we did some comparative analysis of that, and actually proc SQL is a lot more efficient than doing call input X. But is there any other recommendation why you'd choose one over the other?
If you're not concerned primarily with performance, then it depends on the programming logic, but in one of the examples we gave, let me back up here a little bit. So it just lended itself more to a data step to be able to do, let me get back to that slide if I can find it here. Actually, that was on the previous example, wasn't
Yeah,
it?
go back to the control table.
Yeah, oh, it's all the way back there.
Yeah,
Okay, I
so,
gotta go a ways.
so with, because one of the things is that on ProcSQL, it doesn't give you an observation number. And so we wanted to use the observation number, the underscore and underscore, to build that because we needed to keep it in a particular order. Otherwise, with ProcSQL, you can end up reordering your records, and there's no observation number associated with that. And we needed to use that. That's why we went with the data step here.
You can actually get around that by doing a constant assigned by 1 to the observation.
But you're doing a nested macro. You're doing a subquery within. So if you.
It's setting it up with a SQL statement and you follow that with another SQL statement.
Yeah.
Yeah, so to be sure, this data step could be done with some proc SQL code. There's many, many examples throughout SAS where you can do the same thing with a data step or a proc SQL, and it just depends on which is more convenient, which you know better. That's why they say SAS stands for several alternative solutions. All right, and I think we're out of time, so we will wrap there. So go out there and macrotize your code.
Yep. Thank you.